In this instructional video, we're going to discuss relations and functions along with domain and range. So let's start out with a relation, and a relation is simply a set of ordered pairs. And the domain is the x values, while the range is the y values. Now let's get into the definition of a function here. Now before we do this, I'm going to go ahead on the bottom here of this graphic, and I'm going to put a relation. So I'm going to use the set notation and curly cues here. I'm going to put -2, 4. Here's some ordered pairs. So by relation is simply a set of ordered pairs. 5, 4. 9, 4. And let's put one more just for good measure. -3 fourths, 4. All right, so there is our relation. Now, notice here, we're going to define a function here in a minute, but if we wanted to list the domain of this relation from the previous graphic, we would just say, well, that would be the x value. So if you want to put them in order from smallest to largest, we'll put -2, -3 fourths, 5, and 9. And the range of this relation is simply the number 4. So we don't have to write 4 times, so we'll just put is 4. Now let's look up here at this definition of a function. Now this is Young's definition, and it incorporates just about any creature you will come across as we continue. A function is a rule of correspondence such that each different x, now this is huge here, a lot of books don't emphasize this, each different x corresponds to exactly one y. Now notice all the other names that textbooks like to use for x. I mean, they call it domain, which we talked about, first coordinate, first component. Computer people call x the input. Young even put for fun down there the first block, and we'll get to that. And the calculus name for x, for those going way up the ladder, is called the abscissa. And all the corresponding names for y, domain, range, first coordinate, second coordinate, first component, second component. Computer people, input must have an output. A first block must have a second block. And the calculus word for y, abscissa's counterpart, is called the ordinate. Now, before I go on, let's look at this relation that I put here. And it's time to go to the colors. Y'all know I love my colors here. So here's our relation that I've already spoke of. Is this relation a function? Now notice it says, are all the x values different? Now we don't give a rat's you know what about y's, so in this case, this relation, by definition, is a function. Each different x, and the x's must be different, corresponds to one y. Now I had a lady one time whose boyfriend or husband was cheating on her, and I heard her up front there talking to a friend. Now I was writing stuff on the board, and I really don't get into y'all's personal lives and stuff. But it was funny when I was teaching this, because I could hear her going, that no good cheat. I mean, he's cheating on me and so forth. But anyhow, when I started doing this lesson, she never raised her hand on much. But in this one, she raised her hand, and I was like, whoa, and I called on her. And she goes, Mr. Young, do you mean that it's okay for the y's to cheat on the x's, but the x's can't cheat on the y's? And I kind of thought about that and laughed, and I said, that's absolutely right. I think she might have been talking about chromosomes there, though, but I don't know. All right, so let me go on here. That's how she remembered it, so whatever works. And once again, here's the book's distinct definition. A function is a relation in which for each distinct, now I slipped that word different in there, y'all know me, value of the first component. So here's how other books will say it. Now notice first component, another name for what? X of the ordered pair. There is exactly one value of the second component, y. So don't let the textbooks fool you with some of this stuff. All right, let's play with some more relations here. Now, they give you a relation they call f, which we certainly want to avoid on the test. Is this relation up here, and I'll go to green, a function? Now, don't peek down there yet. What would y'all say, yes or no? Absolutely yes, because those x's are all what? Different. So notice again, now you know what I'm surprised about here? They put the x values, they didn't use this word here. Why didn't they say, well, the domain of this relation would be this, and the range of this relation would be this? Go figure, I don't know. Let's try another one. Is this relation a function? Now I'm looking at all these x values, and I could hear that one lady. They're cheating. Well, actually, the x's are now cheating, but they can't. So this one is not a function. The x's aren't allowed to cheat, only the y's. So there's a good deal. Now, y'all don't want one this easy on the test, do you? I mean, I just give you a whole bunch of ordered pairs, and you tell me what the domain and range is, if it's a function or not. Okay, is this relation a function up here? Absolutely. See, again, notice here the y's are cheating, but we don't give a rat's you know what about those. Wait a minute. I see some x's cheating too. So again, if any of the x's cheat, sorry, not a function. I almost missed it. The x is repeated there, so don't feel bad. It's really just a visual thing. Now here's my old first blop and second blop here. Sometimes they'll do what's called mapping to see if things are functions. Now I don't know if that's a blop or not, but that's what I call it. So relations and functions can also be expressed as a correspondence or mapping from one set to another. Did you see how my definition kind of covers all this? In the example below, the arrows from 1 to 2 indicate that the ordered pair 1, 2 belongs to F. So in other words, if I wanted to start writing ordered pairs out of these blocks, we could do it. We could put these ordered pairs right here. And I think y'all will see, is that a function or not? Why, certainly, because this time the x's are different. So we might have to go to a different color here. We haven't used pretty blue yet. This would be a function in terms of the blocks. And notice it says each first component is paired with exactly one second component, or x values, y values. All right. How about these? How about these? If the mapping for relations h, which is not a function, the first component, -2, is cheating. Notice -2 pairs off with 1 and pairs off with 0. The x's would be cheating here. Sorry, no function. Another way to think of a function relationship is to think about x as what's called the independent variable, whereas the input. So notice again, all of these words I talked about, and the dependent variable y as an output. They must be going to the computer people's way of thinking on this now. In a relation, the set of all x values of the independent variable x is the domain, and we said this, the range is the dependent variables or y values. In other words, what this is saying, y will depend on x, especially when we get into functions and graphing and so forth. Y will definitely depend on x. All right, give the domain and range of this relation. Tell whether the relation defines a function. All right, so notice here, we'll underline the x values in pretty blue here. It says the domain is these numbers right here, 3, 4, and 6. And we'll go to a different color here. How about a pretty green? And we will underline the y values. And they tell us that these are -1, 2, 5, and 8. I like the way they arrange that in order, too, from smallest to largest. That always helps the instructors when we're grading. This relation is not a function y. The x's are cheating. So let's continue. I think everyone will have this. And man, we got a lot of examples here on this one. Give the domain and range of this relation. Tell whether it's a function. Now notice here with the blocks that the first block is x, or domain or range, or first component, first coordinate, whatever you want to call it, y, input, output. Okay, the domain is those numbers, the range is those numbers, and it is a function. Notice the x values differ. And here's just another way to pull your chains. This relation is a set of ordered pairs, so the domain is the set of x values, -505, the y's are 2, it's a function. And here they do a little bit of mapping here. It says the domain is a set of x values, so they did this one in ordered pair fashion. They did it on a graph, so all you have to do on the graph is pick out the x's, pick out the y's here, and it looks like to me, I don't know about to y'all, that all the x's are certainly different. So this would be considered a function. Now they give us an oval here on the graph, and they want us to talk about the domain and range. Now notice here, the x values of the graph includes all the numbers between -4 and 4. So let me go ahead and read here, and notice from here to here, and everything in between, the x's range from -4 to 4. Now notice here's interval notation coming back. So we must make sure from chapters previous that we know interval notation. And notice it's got the brackets because it is part of the graph, -4 to 4. While the range, on the other hand, and I'll go with a different color here, I'll go with this violet, the y values range from -6 to +6. And again, in interval notation, you always write that from what? Smallest to largest. Brackets includes the numbers. All right, so they just wanted the domain and range of this relation graphically. And they'll give us another one. How about our friend the line, our linear function we're going to learn about? Now notice on x, this thing is going to go forever this direction and this direction, as that line with the arrows on it here keeps going and going forever. So the domain would be all real numbers from -infinity to infinity. And on y, similarly, this line is going to keep rising that direction and falling that direction. So most lines, except for the ones that are like horizontal or vertical, always have both the domain and range that will encompass all real numbers as that thing extends endlessly to infinity and beyond Buzz Lightyear. How about our friend, the parabola here we're going to learn? Now notice the arrows say this thing's going to keep extending too. So if we want to look at the domain on this one, it's going to keep going on x, and it's going to keep opening wider and wider and wider forever and ever and ever. So if we want to come over here and write the domain, which is what they like to do in a lot of exercises, it would be -infinity to infinity. But y on this one, notice y starts down here. What we're going to learn later on is called the vertex of this parabola. It starts there and heads off in that direction. Now, where is this along the y-axis? And notice I'm using green here, and it looks like they've got it marked at -3. So notice the range over here would start at -3 and head upward, which on y is toward positive infinity. So we will also look at domains and ranges with graphs. And of course, the agreement we're going to make here is, unless specified otherwise, the domain of a relation is assumed to be all real numbers that produce real numbers when substituted for the independent variable, or x. So I hope we got a good review here on what is a relation, what defines a function, both graphically and using ordered pairs. Professor Bob Young signing off.